Hi, I'm Hal Aronson of We Share and We Care Solar, and today I'm going to give you a demonstration on troubleshooting the We Share Solar Suitcase. Troubleshooting is actually a really fun activity. What we're trying to do is figure out why the system isn't working. And we do that by checking the appliances and then systematically working through the circuit that's affected, that's not working. And usually the problem in an electrical system is a loose connection. So what we're going to do is we're going to show you how to do this with a light bulb that doesn't work, and we're going to work systematically from the battery all the way to the lamp socket. Okay, let's start with the troubleshooting problem of a light bulb not turning on. This means that there is not electricity, or at least not sufficient or proper electricity reaching the light bulb. And typically this is caused by one of the following. It could be that the light bulb is not fully screwed in to the base. It could be that the plug on the lamp cord is not fully plugged into the main control board in the light socket. It could also mean that the battery is undercharged or discharged, so it's below 11.6 volts. Or if that's not the problem, it could mean that the electricity is not getting from the battery through the charge controller to the lamp socket. So what we'll do is we're going to walk through how to troubleshoot any of these problems, and we'll start with the easiest one, which of course is the light bulb not being fully screwed in. So let's just take a look at the lamp cord. I'll turn the system on. This is the main switch, so the power's on. And just for fun, I'll unscrew the lamp. We plug it in. We turn on the switch, and the light bulb doesn't come on. So now I try the easy fix, screw in the lamp, hit the switch, and it does come on. Now, if it still doesn't come on, if you have another lamp, you could screw that in just to make sure it's not a problem with the lamp. Now I'll show you the plug not being sufficiently inserted. We turn the switch on and the light doesn't come on, but if we plug it in, the lamp does come on. And if you notice, there's actually an indicator light right here on the lamp cord that tells us that there is electricity at least getting to the plug itself. Okay? But let's say that you have all this right, but the light bulb still doesn't come on. Then the next one we want to do is to see if the battery's got a sufficient charge. So we go to the digital multimeter and we set it for 200 volts DC. We take our positive lead, which is red, and touch it to the metal terminal on the positive terminal of the battery. And we take our black lead and touch it to the negative terminal. And you'll see that the multimeter shows us 12.4 volts. So that part works just great. So the battery's in good shape. Now, does the electricity get from the battery to the battery terminals on the charge controller? Let's check it out. So we take our red lead and touch it to the battery positive, and our black lead touch it to the battery negative, and we get 12.4 volts. That tells us that electricity is getting through the circuit that takes it from the battery to the charge controller. If we didn't get voltage here, then we'd want to check this circuit to make sure that indeed it works. So let me show you what that circuit looks like. So first we'll turn off the system. We'll unplug the battery. And we'll turn the main control board over. And I will show you what this should look like. This is the battery socket. And the red wire goes up to the main switch, and this is the battery side of the switch. It goes in here, the switch closes the circuit, and the red wire continues on to the charge controller where it's screwed down to this terminal. And you can see that the wire is properly stripped, so only metal is on this terminal. Now let's look at the negative side. Again, you can see this wire is properly stripped of insulation, so it's only metal touching metal. And we can give it a little pull to make sure it's snug. And we look back, and that's the negative side of the circuit from the socket to the charge controller over here. Okay, Now, the next thing we would check is to make sure that electricity is going from the charge controller battery terminal to the load side of the charge controller, because the charge controller actually controls the electricity going from the battery to the loads. So we plug the battery back in, we'll turn the system on, and now we'll use our same multimeter and take a voltage reading on the load terminals on the charge controller. Positive will go where this blue wire is, and the negative where the white wire is, and we get 12.4 volts. Because we get 12.4 volts, we know that we're getting the same electricity at the load terminal as we are at the charge controller. So we know that electricity can go all the way from the battery to here, and from this load terminal, the electricity is going to flow in these blue and white wires over to our two load sockets. And what we're checking is the lamp socket right now. So if we didn't have voltage here, but we did at the battery, and it was over 12 volts, and the red light wasn't on the charge controller, then we'd know there was a problem in the circuit between the battery and the loads on the charge controller, and that's something that you can't really fix in the field. What you'd have to do is just move this blue wire over to the battery terminal wire to get power to the socket. That would be the quick and dirty fix. Now let me show you how this circuit works. This goes, I'll unplug this. And this is the blue wire coming from the load side of the charge controller. And you can see it gets bonded to two other blue wires, one to go to this lower socket, one to go to this upper socket. So the light socket, it comes in here, and it goes into this switch. The blue wire goes on one prong, and then a blue wire comes off the other prong on the switch and brings it to the middle of the lamp socket. Very important that it's in the middle, because this is the positive pole or positive prong or conductor on the lamp socket. The white wire, the negative side, is toward the edge, because the conductor for the negative on a socket is toward the edge of the socket, and that goes back into this Wago, which bonds the wires together, and back to the charge controller here. So it's always good to make sure, if you think there's a fault, that all your wires are snug, properly stripped, and even inside these terminal blocks, to make sure that there's a good connection. And every once in a while we'll see that somebody forgets to take this stripping, the insulation, off the wire and sticks the insulated wire into the connector, and of course that wouldn't work as well. So on a switch you'll always see only the positives, and in the socket the blue or the positive wire is going to be toward the center of the socket. If these two were reversed, that would be reversing polarity, which can cause some problems. Now finally, we can make sure that the electricity does get from the charge controller to the socket. So let's go ahead and test this. We'll go ahead and put the battery back in. We'll plug in the battery. We'll turn on the main switch. And the red probe, the positive, goes to the terminal or the contact on the bottom of the socket. And the negative, or the black probe, goes to the metal that's on the rim of the socket. And if you look, you see there's no voltage, but that's because the switch is off. Let's turn the switch on, and we get our 12.4 volts, which means that there is a good connection all the way from the battery through the charge controller, through the switch, and to the lamp socket. That one didn't go.